Hello, Algebra 1. Today we're going to be looking at a fourth method of solving quadratic equations. If you remember, we've learned how to solve quadratic equations by graphing, by taking the square root, by factoring, and then today's lesson will be on completing the square. So before we do that though, I want to do a warm-up problem. So I'm going to give you guys a couple minutes to work on this warm-up problem. Pause the video, and when you're ready, press play. So if you guys remember, what to do as our first step when we're solving a quadratic equation of this form is we're going to square root both sides. And when we square root both sides, we want to make sure we put a plus or minus. And then from here, I'll get x minus 3 on the left side. On the right side, I'll have plus or minus 2. And if you remember, what we did next was we broke this up into two equations. So my first equation would be x minus 3 is just positive 2, or just 2. And then my second equation would be x minus 3 equals negative 2. And then from there, you would just solve each equation separately. Add 3 to both sides. I'll get x equals 5. This is one of my solutions. Solve the second equation, and you'll get x equals 1, and that is my second solution. And so if you remember, the square root method is one of the methods we're going to be using to solve quadratic equations. This is a method that we're going to be using quite a bit today, actually, when we're completing the square. And we'll talk more about what it means to solve it by completing the square. Now, let's do a little recall here. If you look at this trinomial, x squared plus 10x plus 25, we call this a perfect square trinomial. When you factor it, you end up with the same binomial being multiplied to itself, right? This is just x plus 5 times x plus 5, or x plus 5 squared. Similarly, if you look at this trinomial here, this is also a perfect square trinomial because if you were to factor that out, you'd end up with x minus 7 squared. So one of the factors will be repeated, right? You'll have the same factor twice, essentially. So now we're going to figure out what number needs to go in these empty spots so that this becomes a perfect square trinomial. So what we're going to do here is we're going to better understand how to complete the square by using algebra tiles. So here I'm just going to draw them out. So if you remember, x squared was the algebra tile that was a giant square. And then two x's would mean I'd have two of those little rectangles. Each of those rectangles represents x, which is an area of x. And then if you notice though, I don't have a square. And the reason why is because I'm missing something here, right? So what would I need to make this a square? I will need one of those small tiles, right? Those small square tiles that represents an area of 1. And so what that means then is that the number that I need to add to x squared plus 2x is 1, and that will allow me to complete the square, because now I have a square. And so from there, we're going to be looking at the dimensions of our square. This is x plus 1. This is x plus 1. This is like your Punnett square, essentially, right? And you're filling out the outside of the Punnett square. And if you notice, this tells me that when I factor out x squared plus 2x plus 1, I just get x plus 1 squared. And that's how you know we added the correct constant to make it a perfect square, right? Let's take another example. X squared plus 4x plus what? All right, so what number do I need to add there to make it a perfect square? So once again, I'm just going to draw my x squared tile. And again, your goal is to form a square, right? So if I have four of these rectangles, right, four x's, I'm going to stack 2 this way. And then I'm going to stack 2 this way. Now if you notice, we have this missing gap here, right? So what do I need to complete the square? Now if you notice, I need 4 of these little tiny squares, right? I need 4 of them. So if I add 4 of them, then I'll be able to complete the square. Once again, note that the dimensions here would be x plus 2, x plus 2. And when you factor this, this just becomes x plus 2 squared. So this is a perfect square trinomial. So 4 was what I needed to add to complete the square. Hopefully you get an idea of what we're doing here. I want you to try number 3, draw out the picture and figure out what number needs to be added there. So for number 3, I'm going to draw x squared. Then I'm going to draw 6 x's. So I'm going to draw 3 going this way. And then I'm going to draw 3 going this way. And just like before, right, what do I need to complete the square? You'll need 9 of these little tiny boxes. So that tells me I need to add 9 to complete the square. Writing out the dimensions of this Punnett square, I have x plus 3, x plus 3, and in the end, this factors into x plus 3 squared. So the question now is there a general rule I can use to figure out what number I need to add there? And the answer is yes, there is a general rule. What you're going to do is you're always going to look at the coefficient of the middle term. So the 2, the 4 here, the 6 here. And what you're going to be doing is you're going to be taking that 2 and you're going to divide it by 2 and you're going to be squaring it. This will become 1 squared, and that's just 1, right? And so this 1 comes from here. Similarly, I'm going to take that 4. I'm going to take the 4 and divide that by 2, and when I square that, I'll get 2 squared, which is 4. And once again, if you notice, that 4 is what I added to complete the square. Lastly, I'm going to take that 6, and I'm going to divide that by 2 once again, and I'm going to square it. We do division first, and then we square next. And if you notice, that 9 is what I added to complete the square. So keep note of that, right? So in general, if I have x squared plus bx, and I need to figure out what I need to add to complete the square, once again, I'm going to be looking at the number in front of the x term. In this case, it's b. I'm going to divide that by 2, and I'm going to square it. And that's the number that goes here, right? That's the number that I need to add to complete the square. So hopefully you see why this is called completing the square. The last thing I want to mention is when you factor x squared plus 2x plus 1, right? You end up with x plus 1 squared. My hope, if you're ever not sure how to factor this out, what you can always do is look at the number that you had before you squared it. In this case, it's just 1. And that's the number that's going to go here. In my second example, look at the number that I had before I squared it, right? This 2. And that goes right here, positive 2. The number that I had for number 3 before I squared it was 3. And so that's the number that's going to go here, right, when you factor it out. And so what that tells me then for number 4 then is when I factor this out, I'm going to take the number that I had before I squared it, right, which is b over 2. And this is just going to be x plus b over 2 squared. Right? And this is what you get when you factor it out. So we're going to be using this idea here for a couple of examples, and we'll see how we can solve by completing the square, okay? So let's look at our first example together. Here we're going to solve each equation by completing the square. So there's a process to this, okay? The first thing you want to do is you want to just leave all the x terms on one side, and then anything that does not have an x term, you want to move it over. So in this case, I want to add the 21 over to both sides. And so from there, we're going to simplify this up. I'll get x squared minus 20x. I'm going to leave a little space here, equals 21. And the reason why I'm going to put a space there is because I'm going to be adding something here. And because I'm adding something to one side, I have to make sure I add it to the other side, right? Whatever you do to one side, you do to the other. And that number that I'm going to add there is what I need to complete the square. So if you remember earlier, what we did was we took the number in front of the x term, right? We're going to take that number and we're going to divide it by 2 and we're going to square it. And if I do that, I'll get negative 10 squared, which is 100. I would recommend you do it like this, by the way. Now, don't do it all in one step, and you'll see why later. So 100 is what I need to add to complete the square. But I need to make sure I add it to both sides. Now from there, the whole purpose of completing the square is so that on the left side, when I factor it, I'm going to get something like this. Now the right side, I can just add a 121, right? That would just be 121. And then from here, I want to factor out this perfect square trinomial. So to do that, I notice that x squared minus 2x plus 100, if you factor that, will give me x minus 10 quantity squared. Now, if you're not sure how to factor that, what you can always do is look at the number that you had before you squared it, right? In this case, it's negative 10. And if you look here, it'll just be x minus 10. Right? It's that same number that we had before we squared it. Now, from here, this is exactly like our warm-up problem, right? We're going to solve this by using the square root method. I'm going to take the square root of both sides. And whenever we take the square root of both sides, we got to make sure we put a plus or a minus. And then from there, I get x minus 10 equals plus or minus 11. From here, we want to break this up into two equations, right? My first equation is x minus 10 equals positive 11. My second equation is x minus 10 equals negative 11. And then you're going to just solve them both separately. I'm going to add 10 to both sides. I got one of my answers. I'm going to add 10 once again to both sides. And if you carefully simplify this, you get negative 1, and those are my two solutions. So this is how we solve a quadratic equation by completing the square. I'm going to do one more example before I let you try one on your own, because I want to walk you through these steps. There are quite a bit of steps. So just like we did before, the first thing you want to do is you only want to have the variables on one side. So that plus 7, I want to move it over. And I'm going to do that by subtracting 7 to both sides. And what I'm going to do is, once again, I'm going to leave a little space right here, because I'm going to add something to complete the square. And what number is going to go there? Well, to figure that out, we're going to be looking at the number in front of the a term. We're going to take that number, we're going to divide it by 2, and we're going to square it. In this case, 8 divided by 2 is just 4, and 4 squared is 16. And so that's the number that I need to add to complete the square. Here, let me just rewrite the left side for now. On the right side, negative 7 plus 16 is 9. We're just going to simplify that. And so when I factor this out, I'm going to get a plus 4 quantity squared. If you're not sure what this is going to factor into, just note that if you look at the number here that we had before we squared it, right, before we got the 16, we took the number 4, right, and we squared that. And if you notice, this is the same number there, right, a plus 4. And so from here, you're going to solve by using the square root method. So we're going to take the square root of both sides. Don't forget the plus or minus. A plus 4 equals plus or minus 3. And then once again, we're going to break this up into two equations. The first equation is a plus 4 equals 3. And the second equation is a plus 4 equals negative 3. Solve the first equation, you'll get a equals negative 1. And then solving the second equation, you'll get a equals negative 7. And these are your two answers. So there are quite a few steps, right, when you're solving an equation by completing the square. So really take a close look at that, really go through each of the steps and make sure you understand what we're doing. And then when you feel ready, try number 3 on your own. Now for number 3, same thing we did before, we're going to subtract both sides by 8. I'm going to leave a little space here because I'm going to add something to both sides, right? So in this case, let me put a plus, plus. What we're going to do next is we're going to be looking at this number negative 6. We're going to divide that by 2, and then we're going to square it. This becomes negative 3 squared, and this becomes positive 9. So we're going to be adding 9 to both sides. Now, I'm going to rewrite the left side. Negative 8 plus 9 is just 1. And then from here, we're going to factor the left side. I note that this is a perfect square trinomial, so I know that the left side will factor into something to the power of 2. And then from there, I know that this will just be n minus 3. And the reason why I knew that was because, well, n minus 3, right, negative 3, is a number we had before we squared it, right? From here, we're going to square root both sides. Don't forget the plus or minus. I'll get n minus 3 equals plus or minus 1. And then from here, I'm going to break this up into two equations. N minus 3 is positive 1. N minus 3 is negative 1. Carefully solve for n. You'll get n equals 4. And you'll get n equals 2. So see if you got that right. If you made any mistakes, go back and really double check and see where you made your mistake, right? Learn from your mistakes as you're moving forward, okay? So one thing to note is that for number 3, you could have solved this just by factoring and then using the zero product property. But the completing the square method is very useful when you have something that's not factorable. For example, like number 4, right? This is not factorable. So looking at number 4 here, we'll do this one together. Just like before, I'm going to add 58 to both sides because I want only the variables on one side, and anything that does not have a variable should be on the other side. We're going to carefully simplify this out. I'm going to leave a giant space there. And the reason why is because I know that I'm going to add something to both sides. And what am I going to add? Just like we've been doing before, we're going to take the coefficient of that middle term, which is negative 10, divided by 2, and we're going to square it. Negative 10 divided by 2 is negative 5. Negative 5 squared is positive 25. That's the number that we're going to be adding to both sides. From here, I'm going to carefully just simplify the right side for now. 58 plus 25 is 83. And now I can factor the left side. I know this is going to be a perfect square trinomial. When I factor the left side, I'm going to be left with v minus 5. Again, if you're not sure what this becomes, just look at the fact that negative 5 is a number I had before I squared it. From here, we're going to solve by using the square root method. We're going to take the square root of both sides. Don't forget the plus or minus. I'll get v minus 5 equals plus or minus. Now, in this case, we don't know what square root of 83 is, and we can't simplify it, so we're just going to leave it alone. From here, we can break this up into two equations. V minus 5 equals positive square root of 83. V minus 5 equals negative square root of 83. And again, we're just solving for v here. So we're going to add 5 to both sides. Now the thing to note is that you can't add the 5 and the square root of 83 together, so you just leave them like that. Similarly, when you add 5 to both sides, you can write this as v equals 5 minus square root of 83. A lot of times we like to put the number in the front and the radical after. Now, these are your two answers. Now, another way you can actually write this is 5 plus or minus square root of 83. And that would also mean the same thing, okay? So hopefully you see how we completed the square here to solve the quadratic equation. When you're ready, try number 5. For number 5 here, I'm going to add 35 to both sides. Once again, I'm going to leave a giant space there because I know that I'm going to be adding something to both sides, right? Because I need to complete the square. What number am I going to add to both sides? Let's take a look at this 8, right? The coefficient of the middle term. We're going to take that 8 and we're going to divide by 2 and we're going to square it. 8 divided by 2 is 4. 4 squared is 16. That is the number I want to add to both sides. I'm going to simplify the right side. That's just 51. And then from there, I'm going to factor the left side. And when I factor the left side, I know it will be of this form. It's going to factor into x plus 4. Again, just note that this plus 4 corresponds with the number that we had before we squared it, right? From here, we're going to square root both sides. Don't forget the plus or minus. I'll be left with x plus 4 equals plus or minus square root of 51. If you notice, we can't simplify square root of 51. And then from here, you can break this up into two equations. X plus 4 equals positive square root of 51. X plus 4 equals negative square root of 51. And then we're going to carefully solve for x. Just like we did before, I'm going to put the negative 4 in front of the square root of 51. And here it's being added to square root of 51. So you got to make sure you put that plus sign. Subtract both sides by 4 again. I'll get x equals negative 4. This time it's subtracted by square root of 51. Or you can write your final answer as negative 4 plus or minus square root of 51, and that would also be correct. So this is called solving by completing the square. It's not very simple, right? There's a lot of steps to it, but it combines a lot of the stuff that we've learned before, right? Just like solving by square root method, factoring, and things like that. So make sure you guys review your notes, work on your homework problems, and if you have questions, please let me know.